So in this video, we'll continue to look at modifiers. So the modifier we're going to look at now is going to be called a short. So I know short is a data type, but this time around it can be used as a modifier. So now, when you use short ahead of an integer like this one, if you say short here, if you introduce a short, you mean, because an integer is actually 8 bytes, right? 8 bytes in size, and then a short is smaller than that. It should be 2 bytes. Okay? No, an integer is actually 4 bytes. Then a short is 2 bytes. It's a long that is 8 bytes. So when you say, if I introduce an integer here, I say int, okay? Then I'll say a short int. Okay, I'm going to call this one short int. Then I'm going to say, give it a value of 100. So you know that the range for an integer is bigger than the range for a short. Okay, so I'll say cout. So since the range is bigger, than the range of an integer is bigger than the range of a short. So if we compare this, right, it's still going to print out an integer. So if we're using 100 here for an integer, it just means that we have wasted a lot of space, because we could have stored this in a short which has got 2 bytes. You understand, right? So, but if you say short, I can introduce a modifier called short int. So when I say short int, what I'm actually telling the compiler to do is that the compiler should downsize or reduce the size of this integer. Okay, it will reduce it. So it means it creates a small sized version of the integer. This is what the short int means. So it means if you want the integer not to take too much space, okay, or to be reduced in size, you introduce this short here. Okay, so now when I compile, you might not see the actual differences, but the compiler knows that it's created a short sized integer in that case. Okay, so sometimes you find that so this is short int. Sometimes you find that you want to use an integer, but you want to expand its size. Okay, you want to expand its size. So in that case, you're going to use a long. Okay, a long int. Long int means create a greater size of an int. Now expand the size of the integer. So in that case, I can say int. Okay, then I'll say int long. So I'll say long int. Okay, then I'll say long int, like that. So I can give it any random number of any size. Then I'll say cout. Then I'll say long int. Now I'll say end line. Okay, so you can compile that. So when you compile that, you may not see any differences when the numbers are printed out on the console, but the truth is that the compiler, you have instructed the compiler to print out or to print an integer or to increase the size of the int. That's why I've said what? A long. Okay, a long integer. Okay, so now when you introduce a long int, majority of the time you're going to say long. Okay, you introduce a long here, because if this size is not, if you don't put a long here, the compiler, there is a chance, depending on the type of compiler you're using, you might still treat this number as what? As an integer. So now when you compile that, okay, now the compiler knows what you're dealing with, a long integer. So another modifier you should be aware of is a long int. Okay, long. So when you use long, you end up with a situation where you have a long and a long, but an integer. So we're going to say a long int. So it means make the integer, okay, expand the size of the integer twice in size. Okay, so you can introduce any large number even outside the boundaries or the range of the normal int size. But because you said long, okay, now when you introduce a long, you have to put an extension of long, so that the compiler knows that the integer version you're using is a long modified what? Integer. Okay, so then you're going to say cout. You're going to say long int. So I'm just going to print out a long into the screen. So you do that and then we compile. When you compile that, successfully compile, so the compiler knows we're using a long int version. So that is what happens. So in some cases, you're going to find that you just don't introduce a long. You can actually have a situation where you have said we want an unsigned. You can have a situation where you have unsigned. Okay, can have an unsigned. An example is you can have an unsigned long int. Okay, so meaning we only want positive numbers but of the long integer type. So we say long int. Okay, so I'm going to say unsigned long integer. This is C++ words. So I was saying then I'll say long int is equal to, so unsigned meaning it can only be a positive number, okay, to the size. Then the extension is going to be unsigned long integer. Okay, so that is how the extension will look like. I mean, this is what makes C++ fun. It's so meticulously put together, you know. So they're going to say unsigned long int, like that. You say end line. Okay, save. Let's close this console here, then compile. So when you compile that, now the numbers might look the same, but inside the compiler here knows that you have said, let me just output accept only a positive integer, but that is twice the size of the normal word of an integer. So increase it in size twice over. So that actually marks the end of modifiers. So this is what you need to know about modifiers. So in the next video, we'll have to look at an array and an object in C++.